Hey, thanks for coming to my session on making software bill of materials, or SBOMs, actionable. I'm Ciara Carey. I work in developer relations and Cloudsmith, a cloud-native artifact repository. Prior to that, I worked as a software engineer for over 10 years, but it was only since working with artifact repositories, because they deal with your built artifacts, they deal with your signing keys, and they integrate with public repositories, and they have a good idea about how artifacts are built using metadata, that I really understood the software supply chain. So today, let's talk about that software supply chain. Let's talk about the threats to your software supply chain. Let's talk about SBOMs, your software bill of materials, as a way to mitigate against those threats. Let's talk about the practicalities of an SBOM, how to generate, host, and analyze an SBOM. And let's make them actionable. Let's go through a workflow. And we'll finish off with the future of SBOMs. So your software supply chain contains all the steps that go into deploying your software, including your source code, your scripts, environmental variables, IDEs, plugins, your build tools like your CI/CD, your artifact repository, your package managers, and a big part of it is your third-party dependencies. They can be proprietary, but they're very likely to be open source. And here we have that lovely XKCD image, which really highlights open source software, how important it is, and kind of how neglected it is at the same time. Open source is really incredibly positive. Without projects like Kubernetes, Debian, Nginx, Apache, and I could go on forever, technological innovation would be painfully slow. I don't think anybody wants to redo Kubernetes again. So, and that's why, wherever there's software, there's open source software. I think a conservative estimate is that over 80% of software contains open source. So a massive part of securing your software supply chain means securing your open source software. So let's talk about these threats in open source software. So the different kind of attacks on open source software can target how you consume your open source software through these public repositories like Maven Central for your Java, PyPI for your Python, NPM registry for your Node. And some of the targets include dependency confusion attacks, where attackers can guess or gain information about your private repositories, find out those package names, try to push them to public repos, and using the mechanism of updating it, they hope that they'll bring in the malware packages into your codebase. And another type of attack is typo squatting attacks, where they hope that developers will make a typo when they're on their dependency list, maybe in their requirements.txt file or something. And they've posted up a similar sounding package, and they hope that you bring that in. They want to trick you into bringing in malware into your codebase. But the most common source of attack are critical security vulnerabilities in open source, like Log4Shell, which was a critical vulnerability found in December of last year in Log4j, a really popular Java package. Another attack was Heartbleed. This was from 2014, and this vulnerability was in OpenSSL. And they both had a huge impact. So let's talk a little bit more about critical vulnerabilities in open source. In a report by Palo Alto's incident responders in July of this year, they analysed over 600 incidents and over the past year. And they found that vulnerabilities in software were the suspected initial access vector in 31% of cases, second only to phishing. And Log4Shell was the most popular open source vulnerability to be used. When you consider this was in July of last year, Log4Shell was only publicized in December prior to that, and it became the number one attack vector for open source. That's crazy. And other research from 2020 found that in 2020, the Heartbleed vulnerability was still exploitable, even though a patch was released in 2014. That kind of shows us that these vulnerabilities in open source have a very long tail. Well, why is that? Well, sometimes you're using an open source package which has been abandoned, and that package, all those dependencies that that package uses obviously aren't being updated, and that's how these unpatched open source packages get pulled into your system. But probably more likely, patching, maybe it isn't a priority for your organization. Or another very likely thing is that you don't realize that you're vulnerable. You're using a dependency of a dependency, and that dependency is vulnerable, and you're actually still exploitable, even though it's a few steps away. So developers need a tool to help them identify all the components in their software to keep them up to date with their vulnerabilities. I want to highlight a software supply chain attack that really highlighted this issue to the industry. It was the SolarWinds attack in, I think it was December 2020. And it was a big attack on the software supply chain. And it brought a lot of government agencies, big tech companies at risk. And after that SolarWinds attack, the Biden administration published an executive order to improve the cybersecurity of the software supply chain. And in that executive order, they outlined how they realized how important open source software was to your software supply chain. And instead of saying, let's pull out all that unsafe open source, they recognized that was going too far, that open source is really positive, but they wanted to have ways to make it more secure. And in that executive order, they mandated that organizations selling to the US federal government will be required to provide SBOMs, software bill of materials. They instructed the NTIA to come up with a minimum elements of the SBOM. And since then, there's been the Log4Shell critical vulnerability. And after that, the White House brought in all the stakeholders, or many stakeholders, from open source and from big tech. And they came up with this 10-point mobility plan. There was 150 million that big tech put behind it. And one of the 10 points was SBOMs everywhere. They wanted to improve the tooling and the training around SBOMs. Outside the US, the EU have published a Cyber Resilience Act in September. And in that was the first mention of SBOMs. It'll be a few years before that's consulted on and enacted. So I've spent all this time talking about software supply chain. I've even mentioned SBOMs, but I haven't really explained them. So your software bill of materials, or your SBOM, lists all the components contained in a software product. So that includes your dependencies and the dependencies. Also the version number, the component name, and the supplier name. So an SBOM in a standard readable format is really important. This is what drives innovation, what drives automation even, and you can use this to trigger security alerts. And luckily, the SBOM, we have two great standards, SPDX and CycloneDX. They're both great. SPDX leans more into licensing, and CycloneDX leans more into vulnerability management. So SBOMs at their core answers the question, what is in my software? And that's really powerful. When a new vulnerability comes out, you can use your SBOMs to see if you have that vulnerability in your codebase. So now let's talk about the practicalities of the SBOMs. How do you generate an SBOM, host it, and analyze it for vulnerabilities? So let's start at generating an SBOM. So there's loads of great open source tooling to generate an SBOM. And let's go through the different stages of the software lifecycle that you can actually generate your SBOM. So you can generate your SBOM at your source code level. So this is really great. It's really shift lefty, very early in the software process where you can create your SBOM. And the problems with it, though, is that it tends to be a bit inaccurate, especially around version numbers, and it mightn't give you the transitive dependencies. So this is the dependencies kind of information. Another time to generate it is at build time. Now, this is the time that's recommended by the NTIA. And there's some tooling around it, like Cyclone DS, SPDX, but there's not an awful lot of tooling around this. This is kind of needs to be the different ecosystems need to come up with new tooling for this. Another time to generate an SBOM is on the built artifact itself. This might be needed because you might know the specific source code that this legacy artifact came from. It might be the only time that you can generate your SBOM, but it tends to be a bit less accurate. Another time to generate your SBOM, and it has really nice workflows around it, is a container image, so generated from a container image. And some of the lovely open source tooling around this includes Anchor, Sift, and Aqua's Trivi tools. They can both generate an SBOM from a container image. And the positives around that, it can be really accurate. Some of the negatives are it can be a bit slower. It's a little bit later in the software development life cycle. And also, if you don't generate if you build stuff outside of package managers, it's not as accurate. And then the last area I'll highlight is generating an SBOM at runtime. And for example, using this JBOM tool, which can generate a runtime SBOM for Java projects. The benefit of generating it at runtime is that some of the other ways of you generating an SBOM will list all the components in your software, which is actually what you want. But the problem is apparently only like less than 10% of that is actually exploitable. So for security professionals, you want to know what the most exploitable 10% is. And that's where these runtime software SBOM generators come in. They'll tell you what software is actually running, or and what even like what SaaS tools are running, what ports are open and closed. And that will give you a better idea of what is exploitable, because it won't list software that's not running on your system. What would be great is like take the best bits of all the different stages of generating SBOMs and create a mega SBOM generator. So super accurate, but then also give you an idea of what's the most exploitable. But that's not a thing yet. So now let's talk about how to host your SBOMs. So container images can use Sigstore tooling to host their SBOMs. Sigstore is an OpenSSF project that aims to make it easy for developers to design, verify, and protect their open source. And Sigstore's co-sign projects allows you to sign images and attach SBOMs and attestations to container images, and they can be signed as well. Cloudsmith, we integrate with co-sign, so you can do all that stuff using Cloudsmith. The best way to host your non-OCI artifacts, so just your random packages, the best practice is not fully understood yet. You can use databases, sure. You can use dependency tracker tooling. You can use artifact repositories stored as a raw file. But the best practice around that is not fully understood. I've heard some talk about piggybacking on the OCI container OCI artifacts, the way they do it. I'm not exactly sure how that would happen, but let's wait and see. So let's talk about SBOMs and the primary use case of vulnerability management. So let's look into a bit of terminology around vulnerability management again. So what is a CVE? A CVE is common vulnerability exposures. And it's basically an ID about a vulnerability so that you know that you're talking about the same thing with somebody else in the industry. Another thing is a vulnerability needs a scoring system. You need to know how exploitable, how dangerous is this vulnerability. And I'll talk about two scoring systems here. The CVSS is a well-known one. It's the most popular one and has a scoring system from 1 to 10, 1 being the least exploitable and 10 being most severe. And if you Log4Shell, for example, that was given a 10 out of 10 in the CVSS score. That's because it was easily exploitable. It was like the remote code execution was the vulnerability, which is the worst thing that can happen. And it also was very common. So it got a really high score. Another scoring system is EPSS, and that has some predictability in it, predictions on how likely it is that this vulnerability will be exploited. So you have your scoring systems, you have your ID, and then you need like a database in order to connect them all. And the most popular database is the National Vulnerability Database, and that will store all the vulnerabilities with the CVE. But of course, there's vulnerabilities outside of that realm, and there are usually the big ones are the security advisories. So different ecosystems will have their own security advisories, like Rust has one, PyPI, GitHub, and they tend to be earlier in the process. So before you get a CVE, it might be published to one of these security advisories. And I want to mention as well another standard, Connect to Vulnerability Management. So this is a new standard, and it's a companion piece to the SBOM. It's by the same people, the NTIA, and it's Vulnerability Exploitability Exchange, or VEX. And it tries to help when we're talking about false positives. Apparently 90% of vulnerabilities are like not exploitable, and that could be because the software is being patched. The compiler doesn't load the artifact affected code, or some protections exist in your software to counteract this vulnerability. And so you might have a software bill of materials in SBOM, and you only really want to look at the top 10%. You want to be able to order by the worst to the least impactful. And VEX can be really helpful here, but it's not really been used in the wild yet. Although the standard is there, I don't think there's really good workflows around it yet. So it's very early stages, but it's good to keep it in the back burner. So how can an SBOM help with vulnerability management? It's the primary use case of SBOMs is to analyze them for vulnerabilities and to see if any components can be an attack vector for your software products. SBOMs are especially powerful when critical new vulnerabilities like Log4Shell are discovered, and organizations want to know if and where they are affected. And a good way to do this is continuously scanning your SBOM is a really efficient way to check for new vulnerabilities in released software. So let's go into a few workflows. And the workflow just one workflow. The workflow I'm going to highlight is around container images. It's the most mature workflow around SBOMs and vulnerability management. So I'm going to use some open source tooling, Sift and Gripe, both from Encore. Sift can be used to generate an SBOM from a container image. Gripe can be used to analyze an SBOM, and it can also analyze container images or file systems. But here we're going to use it to analyze an SBOM. I'm going to store the SBOM in my Cloudsmith container registry using Cosine tooling. And then I'm going to finish off with an action. When we find a vulnerability higher than a certain level, I want to quarantine my image, and I can do that with Cloudsmith. So I'm going to play a video now of this demo. So here we are in Cloudsmith. This is a repository, and you can see that there's nothing there. Loads of different types of packages can go into the same repo as they're multi-format. So let's push a Docker image to our Cloudsmith repository. It's a Ruby image that I'm pushing. And if we go back to the repo, we should see this image being synced up there. And you can see Docker image is just being pushed to Cloudsmith. So that's number one. I've pushed a container image. The next thing I want to do is to create a SIG-store pair, a key pair to sign the image. So I generate a private password for the private key. And now I have a cosine public and private key. Now I'm going to sign the image, And that's going to be pushed to my container image in a layer, that signature. And if we go in here into our Docker image, we can see that the signature has been added to a layer in that container image. So the next thing I want to do is to generate an SBOM using the SIFT open source and core tooling. So you can see here, SIFT, Docker image name, output in SPDX. And we'll just wait for it here to complete. Loaded the image, parsing the image. And now this is going to be attached to a layer in that OCI image. Looks good. Let's check back in the Cloudsmith registry. Now, so here, let's have a look at that SBOM, this SPDX SBOM. There you go. This is the SPDX standard. And you can see it contains a Debian package. So now let's push this SBOM to our container image using cosign. And it's going to be signed as well. Let's go back to our, there we go. I put in my password. Let's go back to Cloudsmith. We refresh the page, we should see the SBOM in a layer in this container image. And now we can actually verify that signed image. So using the public key. And that will verify that it's been signed by me. Yeah, signatures were verified against the specified public key. Cool. So let's extract that payload from the container image. And here we use this, we extract it out there using jQuery. And now we have extracted the signed SBOM from our container image. And now let's generate all the vulnerabilities using open source tooling Gripe. Brilliant. So we've created a vulnerability JSON file. We can actually also push that to our container image in another layer as well. And we can sign that as well as an attestation. So the next thing we want to do in our workflow is to actually quarantine that image if there's a vulnerability above a certain level. And you can see here, we are checking to see if the vulnerability, if Gripe fails, then we're going to fail and we're going to quarantine that image. We're just getting the slug there. And we're going to quarantine that image programmatically. Cloudsmith quarantine add. And that's using the Cloudsmith CLI. And so that means I can't deploy that image to infrastructure or download it. So there I've showed you a workflow of how to push an image to Cloudsmith, generate the SBOM using open source tooling, push that SBOM and host it on Cloudsmith's container registry using Cosign. Grab that SBOM, extract get the SBOM payload from it, check if there's vulnerabilities using Gripe open source tooling, and if the vulnerabilities are above a certain level, I want you to do something actionable. And here, the actionable thing that we've done is to quarantine the image. So now let's talk about future work. So SBOM tooling is allows you to, when a new vulnerability comes on board, that you can use your SBOMs to find out if you're vulnerable, if your code base is vulnerable. And it's great when to have workflows around SBOMs, but really that's where a lot of the future work needs to concentrate on. More tooling, better workflows, so that you can practically bring this into your CI/CD and to use it as a developer, as a security person in the development team, as a vendor, and as an end user. So, but you can generate your SBOMs now using tooling, and I expect that this tooling is only going to get better. These workflows are only going to get better. So yeah, generate your SBOMs. Try to make vulnerability management in open source security software a little bit easier. And yeah, do that. Okay, and thanks for listening to my session. Talk to you. Bye.